The last identities that we're going to add to our list are the half angle identities, and to derive these, which you won't have to do, but just to show you where it comes from, to derive these we're going to start with the cosine 2a that we learned in the last section. If I take the form of cosine 2a that says 2 cosine squared a minus 1, then you can see that when we use this identity, we went from a double angle to a single angle. That's called a double angle identity. But if I look at a is half of 2a. So I'm going to solve for cosine a, and that gives me the half angle identity. So first thing I need to do is add 1 to both sides. So I'm going to have 1 plus cosine 2a by adding 1 to both sides equals 2 cosine squared a. Next thing I need to do is divide both sides by 2. So both of these terms need to be divided by 2. Now I have cosine squared a, and I want just cosine a. So I need to take the square root of both sides. When you take the square root of both sides, you get a plus or minus out front. And then just that fraction that we had, 2a over 2. So pretty simple deriving process to get from a double angle to a half angle identity. The plus or minus and the square root stay in this identity. There's no way to get rid of it until we know what quadrant angle A is in, and then we can choose either plus or minus based on that quadrant. Now usually you don't see it written in terms of A and 2A. To make it look more like a half angle identity, we want to rewrite the A as A over 2. So I'm switching sides here, and I'm going to write cosine A over 2. Now the relationship between this angle and this angle have to be the same. A is half of 2A. So if I call A over 2, then when I write my square root fraction over here, I just need to take twice this angle. 2A is twice A, so this angle right here has to be twice A over 2. 2 times A over 2 simplifies to just A. Okay, so it doesn't really matter what you call your angles here, but it does matter that they have that relationship, that the one over here, which is going to be your special angle, is twice this angle that you started with. That needs to be added to your list. Now we could go through and use another version of cosine 2a, use the 1 minus 2 sine squared, and derive it, and we would get a similar identity for sine a over 2. But I'm just going to give that to you. Sine a over 2 is plus or minus the square root of 1 minus cosine a divided by 2. Notice that these identities are different only in the sign of the numerator, which could help you to memorize them. And then we have 3 versions of the tangent half angle. Tangent A over 2 is going to be sine over cosine, and if I take this radical here and put it over this radical here, I'm still going to have the plus or minus out front. But my divide by 2's are going to cancel out, just like they do when we're finding values for tangent. So I'm going to have 1 minus cosine A on the top, which is this numerator, because it goes with sine, divided by this numerator, 1 plus cosine A. Another version, or the 2 other versions of tangent A over 2, do not have a plus or minus out front. And they're similar in their versions as well. If I put 1 minus cosine A on the top, then I have sine A on the bottom. And then the other version of that is sine A on the top and 1 plus cosine A on the bottom. Notice if you can get this one based on your sine over cosine, then to get these without the radical and the plus or minus, you just take this numerator and let it be your numerator without the radical over sine A. And then if your sine A is by itself, either in the denominator or in the numerator. And then the denominator here has 2 terms, and it matches the denominator of this version of the tangent A over 2. Next, we're going to use these identities in the same ways that we've used the other identities.